Alright, welcome to my third LeetCode video, where I'll take you through my process as I encounter a random problem for the first time, and I'll show you how I go about solving it, for practice for interviews and stuff. As this is my third video, don't expect the best work, but we can learn together. Alright, so we'll do another easy one today. So we'll pick one. Alright, and let's get started. Alright, so number 1436, destination city. You are given the array paths, where each element of paths corresponds to two cities. That means that there exists a direct path going from city AI to city BI. Return the destination city that has no outgoing paths, pretty much. Oh, this seems a bit tricky. Let me write that down differently here. Oops. Paths I means a path. City A, we'll just call it AI like that. And city B. I means there's a path between, or not between, from city A to city BI. And we want to find a destination city. So we want to find a city that doesn't go to any other city, so a city that never appears in the first path. In other words, the city does not appear in the, what do you call it, let's call it the left side of paths. Yeah, you get what that means. Guaranteed that the graph of paths, there's no loop. Okay, good. So immediately this looks like it could be a graph problem, but as it's a pretty simple everything's in a line, there's no loops, it's a very simple graph. We might not have to use any fancy graph algorithms, but let's go through these examples here. So we see that we go from London to New York, and then New York to Lima, however you pronounce that, and then Lima to Sao Paulo. I actually don't know how to pronounce that. And we know that Sao Paulo is the only destination city. Alright. And this is a pretty simple one, it's just in a straight line. Alright, this one we go from B to C, and we can also go from D to B, and then we can also go from C to A. Now B to C. Well, C goes to A, so C is not a destination city, and neither is B. And then you go from D to B. Well, so D is not C to A, so it must be A. Then A to Z must be Z. Yeah, these can look straight to the path. That can be between 1 and 100 different paths, and there's always just two. Always a path between just two cities in each element. City. What does that mean? Is that just the name? The name of the city? I'm guessing that's what that means. The length of the city is just the name. And they're never the same. And all strings consistent. Alright, so let's just go through my first thoughts. Looks like a graph problem, although simple. I don't actually think we'll be needing to use any fancy graph algorithms, because it looks like a bit too simple for that. It might be a bit redundant. Looks like we just need to find which city appears on the right of paths, and not the left. I feel like this is the approach we're going to go for. That seems like a pretty good, at least a pretty good start at least. So how can we do that efficiently? We'll start off with a brute, discussing a brute force approach. So we could just iterate over paths, and then keeping a record of which cities we've seen, and if they've been seen on the right, no, on the left side. Wait, yeah, because if we get to the end and there's a city that we have seen but it hasn't been on the left side, then that would be our destination city. So we need a way to keep record of what we've seen. Immediately my mind goes to a hash map, because it's always a hash map with these problems I've seen. But is a hash map necessary? Yeah, I think so, because we can hash the names. So we can use, this isn't really a brute force approach, but maybe it still is. You can use a hash map, hash the names of the cities, so we can store them later. No, not store them. Look them up later. Store values denoting if they've been seen on the left or right. So maybe we can do we'll do like e.g. city A. Oh wait, hold on. City AI I'm just trying to think, because how they've specified it here. City with little I there. Does that mean it's any different? That New York's different to that New York? I don't see why it would be. I'm not sure why they've got the little I there. I'm going to assume that there's nothing to worry about. But anyway, so city AI equals, we can say 0 if it appeared on the left, 1 if it appeared on the right. Left. It can appear on both. We'll do 1 if it appeared on the left, 0 if it appeared on the right. Left case dominates. So, trying to think. If you come across it on the left, I forgot to have the timer running again. Oh well. So as we traverse the paths, if one's appeared on the left, we put it in as 1, but if we see it on the right later, it stays at 1. Hopefully that makes sense. I think that's a good approach. And if we look at the time complexity, well, we have to just iterate over paths, the elements of paths, all of them once, and that looks like our dominant sequence, of operations. So I think it's O of n, and there's the number of elements in paths. Time, yeah. And if we do space complexity, well, if we're using a hash map, we will have to create, use memory to store that hash map to put it somewhere. Is that big O of n? I believe it to be so. Oh yes, and is it big O of n? Because for every element of paths, we will have to look it up in the hash map and store it. And those operations in hash maps, they technically are big O of n complexity, but the average case is big O of 1. I think that should be alright. We can come back to that after. But I think it's time that we can code something up. Alright. So create a map. I haven't actually made one before. I think it's an unordered set. And then it's a string that we're looking for. Or is it a... No, it's a string. Because paths is made up of strings. Paths seed. I'm not sure if that's correct syntax, but we can come back to that. Paths. So for int I equals 0, I is less than paths dot size plus, and then we want to iterate over both of the cities inside. J equals 1, J is less than 2, J plus plus, iterate over paths. I'm just comment that out. Alright, so now we want to first we check if city has been seen before. I don't actually know how to do that. With a hash, which operation that is. It's like if it's in there or something like that. We'll come back to that. And then, oh no, that checks it pretty much. If not seen, if it's not in there, then add a city. So yeah. If not seen, add city to the map. Wait, do we do that? Or do we check if it is in there and then do else add it? I think maybe. Check if it's the I'm getting a bit messy, but hopefully it'll be alright. So add the city to the map, and then if j equals 0, means it's on the left. Set city to 1. Else. Oh man. I'm trying to think. I need to figure out how to check if it's in there. I might have to look it up. I don't want to, but I really don't know. It's like, I don't know. Unordered C++. You know, we'll look this up and then we'll know it for next time. So what do we have? We've got, is it find? Believe that looks right. Alright. Is that the best way to do that? Yeah, I think so. Or do you use count and then it's just like 0? Yeah. Count might be better. I'm not sure if it's the correct practice, but should be hopefully alright. So we do scene dot count. So if it's 1, if it's in there. Else. Oh, how do you insert it? It's not just like inserting, is it? I'll make a guess and then we'll look it up. So it might be pass scene. Oh no, I've forgotten something there, haven't I? Oh yeah, I have, because we have to put a vector in there. But the name is a string. Is it just string vector string? I don't know. Why is this a double vector? Vector of paths? No, vector. Yeah, no, that makes sense. Alright, I'm just gonna have to look up how to actually use an unordered map. Oh, nice formatting. Let's look at the example. So which one's which? This is true, this true. Is this working if I refresh it? Well, we'll get an error if that's wrong. And these might be swapped backwards. But, so insert. Oh man, I'm not very good at this. I just had it. Where'd it go? What? Oh no, I'm a bit lost. Insert. I don't know if it's just like that. And then the number. Oh yeah. There's a number somewhere here. Might be like that. That should just be a number, I think. Or, oh no, I'm not sure what I'm doing. Well, we insert 0, means it's on the right, and then if it's on that, oh goodness gracious. Or maybe we do it at the same time. I was on a roll. I'm stuck on the coding part, that's not great. So that means we saw it on the left, else we only saw it on the right. The only difference is now that if we see it on the right first, and then we see it again later, if it's on the left, we are in trouble. Okay, so check if it's on the right. Paths seen. How do I access one? It's just like that. Is that it? It looks like it. Paths seen. J. Oh wait, no, this is. Oh wait, no. Hold up. If J equals 2, no, not 2, 1, that means it's on the right. We'll just put that in there now. We can join them together if we need to. Lots of nested statements here. Alright. Paths equals 2 equals 1. Wait, no, I'm checking the wrong thing. Oh, I'm stuck. if it's on the left and we've seen it, if it's on the left and we start on the right first, then we have to if it's on the left, and we first sort on the right. So I think I can join that in there as well. So if j equals 0, which means we're looking at the left element, but paths seen.j equals 0, I've kind of made that a bit. I've kind of got the 0 and the 1 backwards. Maybe I should change that real quick, just so it's easy to read. So 0. There, so what do I have to, oh no, I just confused myself even more. So if it's on the left, it's on the left. Yeah, so it's on the right. This part looks right. And now if it's on the left and we've seen it on the right before, then we put it to the left. Is that it? That looks pretty good. And then we have to find whichever one is 1. Find which return element paths. Yeah, in paths. Seeing that is to 1. How long has it been? It's been about almost 30 minutes, which is not very good for an easy question. I'm not looking forward to doing a medium question next time. No, why am I looking up stuff? I'm looking for a easier find operation, otherwise we can just iterate through them all. Oh yeah, I think I might have messed something up a bit. But I'll see if that's just like a better find operation. No, you're gonna yeah, I guess you can't look up through the values, can you? Oh dear. Oh dear. Uh-oh. How do I do that? How do you iterate over a hash map? Is it different? Maybe it's not. It looks a bit tricky there. Oh dear. Oh, that should also be. I always forget. Alright. Just look at this example. They've got this on the map. Okay. Yeah, I've completely messed this up. I might have to look it up. Well, we try doing it without looking it up, googling it first. So 0. Oops. It's less than. Oh, this is not correct. Oh dear, I'm gonna have to look it up. How to search for a key value unloaded map. Let's look at Stack Overflow. Element in a map by its value. Oh dear. I've maybe done something silly. Okay, let's just see how to iterate through a map. Oh, perfect. Ooh, 6 new methods. We'll look at this one though. I think I set up my map incorrectly. We'll just do what this one does. So, yeah. There we go. Order equals paths scene dot begin. Is that right? What's the difference with having that? Well, yeah, we'll see out it just to see what it. Actually, no, we'll do a test. Trying to get this right first time and then run it. If paths seen. Oh, is this I? Do you do left and right? I mean, first and second, is that how you do it? Oops, I right equals 1. Return I dot left. Else return a space. This is not going to work, but might as well try. Many errors will occur. Yeah, I knew it. I set this up wrong. So, oh, why have I been using another set? Is it not a map? Am I silly? Right. Oh, I must have got 2 there. Right, I need 2. I knew this was my weak point. The actual hash map itself. What seems to be the problem? Look at again, not insert, just creating it. Other than that, I've never done one before. Which strings which? It's not very helpful. trouble. Well, why is this one not working? Why is cat not work? Oh, what are we looking for? Oh, I didn't put anything in there. I'm done. Oh, it's also on some silly I.J as well. What? What's this? Right there. I'm just looking for a way to change the element. Is it not just like you go there, you go there? What? Yeah, is that not what I did? So we've got the string here, we've got these strings. Why'd they make it so freaking annoying? So seafood should be the name of the thing in the bakery. So seafood should be Barbara, shouldn't it? Yes. Why is that? Is that not what I did? Why is this one? Ooh. It's that way. No, it's not LY. What? Oh, why have I got freaking two equal signs? Am I dumb? It's still not right. What's wrong with that? What's wrong with that one then? No matching member function. Back to insert. Just look at the example. That's easy, the easiest way. What, do I have to make a pair or something? No, I shouldn't. Alright. What's wrong with that? Oh man. man. Okay, I don't want to copy one. I want to just insert one right there. Sort of like that. But just one. What's wrong with that one? Let's just experiment with some different things we can put in there. So if we just did that, it's gonna be too quick here. Run. Let me run it. Yeah, it doesn't. What if we just okay. Trying to just get rid of that, just get rid of them, just get rid of them. Output nothing, output not. Oh no, I'm looking at the wrong thing. Okay, so that's what we B C B D C. Yeah, we're outputting what's on the left, which is good. I'm not sure why that doesn't work then. Oh man, it's been 45 minutes. I'm not inserting it right. Okay, so I've got their thing, and then they insert something. I have absolutely no idea why this doesn't work. Okay, what if we make it a pair? Actually, no, what if we do that? Just do that. It's a string. It's a string. No. What? I can't read these error things. I'm going crazy. Oh, can someone tell me why that doesn't work? What's wrong with that? We're trying to insert the string at paths ij with the integer 0 like that. Come on, man. Got it. Perfect. No, it's useless. Oops. what would it say? Ah, but it does exist. No, it doesn't. Is that really just what I had to do? Doubt it. Never works. So why? Oops. Why would it work now? Please. Ooh, looks good. Imagine if I knew how to use hash maps, I would have had this done in like 10 minutes. So that's going to be down here, the error. Right. Maybe. Yeah, it's supposed to be like that. Yeah, I'm not sure what it's called here, to be honest. What is it? Value? Is it the key? Probably not. There's no chance. What's it called? How do I know what it's called? I lost. That was on. No, I just want to iterate through them. Oh, look at this one. See, they've got a first and second, and they haven't declared those names anywhere. What if I did that? Surely not. No. Hmm? After the wrong one. Second. First, right? Oh my goodness, I've done it. Oh, good. Thank you. Hopefully it's right. I submit that. Oh, goody. Just write down how long that took. 49:10. Great, good gracious. I mean, yeah, I got the algorithm. It's just the coding for this one. That wasn't too bad. Hopefully that was a good enough solution. Where is it? Hash set. Okay, there's nothing after the hash set, which is good. But first, their brute force. They did that. Oh yeah, that was a very brute forcey brute force. So I see. Alright. So I went straight to the hash set, which is good. I did use it on the set. I'm not sure the difference. I'm going to use unloaded unloaded set. I guess, yeah, you could have had a set and only held it in there if it was on the right and removed it if it ever appeared on the left. You could have done that. Okay, no, they did the opposite. So, expensive. You can check if a given candidate as an outgoing path. Oh no, yeah, I get it. So maybe mine wasn't the best. I might rewrite a better one then. So iterate paths over again and select a new candidate. Yes, that's probably better, a bit more efficient than mine, to be fair. And then oh, is it? Yeah, so what does mine actually do? Mine iterates over the paths, and then first it checks the left city, and if it's been seen before, then if it's been seen before, hold on, no, is that right? Yeah. Oh, do I need that? I'm just trying to think. With the J, checking the J equals 0, if we just put J there. But then I think when J equals 1, if it's right, with accessing it and everything just to keep it the same, I think, which is a bit silly. So if we're on the left and we've seen it before, so if we've seen it before and the city's on the left, but we've got it recorded as last being seen on the right, and we'll set it to the left. Yeah, right. Else, if we haven't seen the city before and it's on the left, we insert it saying we saw it on the left. Else, we insert it saying we saw it on the right. So then after that, we will have the map of paths seen with cities that we've seen that are on the left and cities that we've seen that's on the right. So there's only one on the right. So then what we do is we just iterate over the hash map until we find a city that was last only seen on the right. And what they do is they create a hash set that only has cities on the left, and then they iterate over all the right cities and check if it was in the left, or if it was in the set, so if it ever appeared left. Yeah, so I think theirs is a bit better than mine, to be fair, because mine makes a big theirs goes over paths once, but on the left side, and then it goes over the right until it hits a destination city. Mine goes over the left and the right, and then goes over it again. Yeah, I think that's right. Alrighty, but it's the same time complexity. Ooh, is that true? What is this? Why is there a poem in the replies? Who does that help? Try. Damn. This fellow looked at it as a graph problem. I made a graph. Okay. Oh dear, I'm not good with the graphs. Okay, the top rated solutions. 4 lines. Yeah, it's just the exact same as the editorial. When was this? I wonder when this was posted. December 15th. No, this doesn't have a thing. On the same day though, so maybe it's the same fella. Or one of them copied the other. How good is mine there? Mine beat 60% in both, that's not bad. Yeah, I'm pretty happy with mine. Could be worse, could definitely be better though. Well, thank you for watching me struggle through coding a hash map. But, I mean, to be fair to me, I got the algorithm right at the start. I mean, it's barely a brute force. It's probably not a good name for that. Probably skipped a brute force. And I missed the editorial solution that they did, which is probably a bit better. Oh, excuse me. But, I mean, I think that's acceptable, this solution. Yeah, I don't think it's as optimal as I like that one a lot. Yeah, that editorial solution. But I think that's my third LeetCode. I think that's pretty good. But yeah, just got some practice to do with the actual data structures, and the operations. Oh well. But thank you for watching. Leave a like if you enjoyed, which no one probably did enjoy. Watching me struggle. Comment any feedback you have. All the good stuff. Yeah, that's it. Thank you for watching.